Hello, today I'm gonna introduce my Shiny app. It's for experimental analysis and experimental design. My targeted audience are statisticians who want to do experimental analysis or students who are learning experimental design and analysis. So Stats 309 is a very good course to take, and students can use my app to simplify their analysis. For my app, I want to first introduce all the tabs on the right. It corresponds to different components of experimental analysis. And then I will go back to the left sidebar to introduce what are these options. Seems there are a lot. So the first tab is to visualize the data, to have an overview of the data. You can go to different pages, and you can also sort by different columns. That's the first tab. For the second tab, it's the box plot. Box plot, the assumption of experimental analysis is that different groups need to have similar variance. So from this plot, you can see, oh, they actually have very similar variances. They don't need to be exactly the same. And also it can kind of help you see what's the mean of different groups. Similar to a box plot, you can see the scatter plot. If you want to have a zoom in a little bit to see more details, to see where are exactly these points, you can use scatter plot instead of box plot. A box plot gives you an overall picture. To get the statistics of the variance, you can use the table tab. It gives you an HTML table, and you can sort by a lot of different things. For example, if you want to check the equivariance assumption, you just sort by the group variance. You can see there's not a very big difference, so it's probably fine for meeting the assumption. So these three tabs are for checking the equivariance assumption. And then you could see the main tab. This is a big part. So it shows you like how powerful is our treatment. Like the more like the higher the slope, the more effective is the treatment, or different levels in this treatment are acting on the response variable, which is y in this case. And so this gives the main effect, and then also we can see the interaction effect. So for interaction effect, it shows us how two treatments interact with each other. If these two treatments do not have any relationship or do not have any interaction, these two lines should be parallel. But if you see this one, these two lines are not parallel at all, and they even intersect. So it means, oh, interaction here plays a role. Or in other words, in this example, water and brand together make a difference. These are the two effects: main effect, interaction effect, and then we go to NOVA. So if we see the NOVA table, the p-value here is very valuable. It tells us like how important it is. The lower the p-value, the more powerful the treatment is. You can see all three rows are significant, are like very, very low. That's the lowest value we can get in R. So it means our interaction and the two main effects are significant. Of course, you need to check assumptions for ANOVA. So these two plots are checking the normality assumption of the errors of the residuals, and these two are checking the independent and identically distributed distributions, the assumptions. You can see, oh, there's not a big difference across different groups, or it doesn't see a trend when you increase the row number. So probably they are independent. So it meets the assumption. And then the last thing is the post hoc analysis. It means, we see one treatment is effective, is statistically significant. Then what levels, or like in one treatment we might have a lot of different levels. What levels plays a role? So the post hoc analysis compares pairwise comparison in one specific level, in one specific treatment. In this case, it's water, which is x1. You can see like 5 jobs, 15 jobs. That's a pairwise comparison. And when it is red, it means they are all significant. Because I give the confidence interval here. If it doesn't contain 0, it means it is significant. So in this case, everything is significant. If it's not significant, well, we can see this one. Okay, you can see none of them is significant. And then you see everything is in black. That's how it works. Okay, then let's go to the left. So let's go back to Tower 2. It makes things easier to explain. So you can see y is the target variable. It has to be numeric. And then we have x1, x2, x3. These are the treatment. If you only have 2 treatment or we only have 1, we can leave the remaining 1 or 2 treatment to null. Definitely has the option to do that. Then for the color, it's like color by. In this case, I color by brand. And also for several other plots, you can facet. So instead of 1 plot, you can have 2 plots. For example, here you can see you can facet by brand. This is very powerful when you have a lot of treatments. When you have 4, it makes things easier to see. I hope this boosts the user experience. And also for the same scatter plot, if we get a lot of points, we want them to be more spread out. And so you can use jitter. This is the jitter width. If you change to a lower value, you can see they are more condensed. You can see a larger value, they are more spread out. It depends on the data set and the number of points you have here. And the next one is a very powerful tool. So the main effect and interaction effect, you can see what's the label. In this one, I've labeled the mean of the group. Also, you can label the effect. I would ignore the concept here, but if you calculate by hand, it might take you an hour. So this one, I give you the plot, help you visualize it, and then I give it a number. Then this is very statistical. You enter the normal formula. You can see go to memory. There's the formula is very different because there's different type of experimental design. And the last one is alpha. It's used for comparison tab, like what's the alpha level you want to use. Yeah, the last one I'll show you is uploading on, because always you have your own data set. Right, you upload it on, and you can see this is your own data set. I wouldn't introduce everything, all the tabs again, because it's already 8 minutes. I hope you enjoy my video, and I really hope my app can be helpful.